how you could use trig ratios to find missing sides in your right triangles. Today, we're going to talk about how you can use trig ratios to find the missing angle, so that theta that they may refer to. Okay. All right. So first, in this top set of boxes, we're just labeling sides. So if this is my angle, theta, what is opposite from that angle? Good. What's adjacent? Good. Which would make this side the hypotenuse, right? Okay, on this one, what's adjacent there? Good. And what's opposite? Which would make this the hypotenuse, right? Okay. And then on this last one, here's my angle. Which one's the hypotenuse? Which one's opposite? And adjacent. There we go. Okay. All right, and we learned this little acronym right here, SOHCAHTOA, to help us remember what order we set up our ratios in. So, for sine, what's our ratio? Good. Okay, for cosine, what's our ratio? Good. And for tangent? Very good. Okay, so let me ask you this. When we were solving, last time we were in here, you don't have to write this down, but let's say you ended up with something like x times tangent of 27 equals 13. How did you get x by itself? You just divided, right? Because that's the opposite of multiplication, which is what's currently happening here, right? Or let's say that you ended up with tangent of 13 equals x over 12. Then what did you do? Cross multiplied, or what with the 12? Just multiplied by 12 on both sides, right? Because that was the opposite of dividing by 12, so that it would go away, right? So basically, whenever we're trying to get rid of something in an equation, we always just do the opposite operation, right? So they're saying that this time, your x is not going to be one of the sides. They're going to give you some numbers to put in here. Your x, or your unknown, is going to be the angle. They're not going to give you a number there this time. So when it comes time to solve, you might end up with something exactly like this, like sine of theta equals 6 over 7. Okay? So I'm trying to get rid of the word sine that's with theta, right? So in order to do the opposite operation, we do the inverse of that. Okay? So the inverse of sine would just be putting in that ratio of opposite over hypotenuse. Okay, this little -1 right here as an exponent, that represents inverse. Okay, it just means we're going to do the opposite operation. And that is how you will solve for theta. Okay? It's going to be the same for all of these. So if you're looking for theta and you have cosine, you're going to take the inverse of your ratio. And the exact same thing for tangent. You take the inverse. Okay? So, when it comes down to solving for theta, and the last step is just to get rid of sine, cosine, tangent, whatever may be in front of it, we just take the inverse. Okay, and we don't actually have to do that by hand. There is a button on our calculators. When we get there, I'll show you that. Okay, so first we are looking at sine. Okay, so we already said sine is opposite over hypotenuse. In this figure, what's opposite of theta? Good. And what's our hypotenuse? AB. Very good. So if I was trying to actually find theta in this problem, and this is what I ended up with, I would take the inverse of CB over AB. And they will give you some real numbers for CB and AB. Alright, so let's give that a try on an example with some numbers. Okay, so it says in this box, these are sine examples. So we are looking for the missing angle. There's the angle they're referring to, theta. So I am looking for sine of theta for our ratio opposite over hypotenuse. Well, what's opposite and hypotenuse here? Very good. Okay, so now the only unknown is theta. To get theta by itself, we just take the inverse. So I'll have that theta is equal to the inverse of sine for 7 over 11. Okay? And we are just going to type this into our calculator. Now, anytime you are finding theta, you are finding the degree of an angle, right? So you are going to round to the nearest degree when looking for theta. Okay? Alright, so on my calculator here, make sure you're in degrees, right? Go to your mode, check, make sure it's saved for degree. Alright, I'm going to type in exactly what we wrote. So you have to press the second button, the blue one, and then sine. See how above it in blue it says sine inverse? Okay, so I'm going to click that. It opens a set of parentheses, and in my parentheses I'm going to put 7 over 11, close parentheses. This is what we get, right? Okay, I'm rounding that to the nearest degree, so nearest whole number. So 39.5 would round to, okay. So theta is 40 degrees in this problem. Okay? All right. Same thing here. There's my missing angle, so sine of theta equals, what's my opposite over hypotenuse here? Good. Alright, and so how am I going to find theta? Inverse. Good. So theta would be equal to inverse of our ratio. Alright, and what do we get on that one? 54, very good. So theta in this problem is 54 degrees. Make sure you do put that degree sign because we are referencing an angle, right? Okay. Alright, we got one more over here. So sine of my angle theta is equal to what's opposite over hypotenuse here? Very good. Okay. So we want to find theta, we just take the inverse. And what do we get there? 49. Very good. Okay. Fun. Did they only give me opposite and hypotenuse here? No. So they actually also gave me adjacent. So I could have used cosine, adjacent over hypotenuse. I could have used tangent, opposite over adjacent. Doesn't matter, because I'm looking for that angle, whatever ratio I use, I should still get that it was 49 degrees. Okay. Alright. Let's flip it over onto the back and look at some cosine examples. Okay, so we know cosine is good. In this figure, what's adjacent to theta? Good. And hypotenuse? Good. So if I was trying to find theta, I would just take the inverse of that ratio, CB over AB. Okay, so it's going to work the same way on these next problems. So here's my unknown angle. So I'm looking for cosine of theta, and it is equal to adjacent over hypotenuse. What's that for us? Good. And if I want to solve for theta, what should I do? And we end up with theta being good. All right. Let's do another one. All right, we've got our angle theta. So cosine of theta is equal to what? Very good. So we take our inverse, and we end up with theta being equal to, good. Okay. All right, last one in this box. Here's theta. So I have cosine of theta is equal to, what is my opposite? My adjacent over hypotenuse. Okay. Okay. So when we want to find theta, we just take our inverse. And what do we get? Okay. So now that we have cosine and we've already gotten sine down, let's double check it with sine, see if we get the same thing. So for sine, I'm looking for opposite over hypotenuse. What would that be here? All right. So we take our inverse of sine, and what do we still get? Right. Very good. All right. Now we just need to go over tangents. Okay, so we know that the tangent ratio is opposite over adjacent, right? In this figure over here, what's opposite of theta? And what's adjacent? Good. So, if I wanted to find the inverse, I just take the inverse of tangent for that ratio. Okay? Alright, so first example, there's my angle. I've got tangent of theta is equal to what? Good. So I'm going to take the inverse, and what do we get for theta? Good. Alright. Same idea on this next one. There's my angle, so I have tangent of theta is equal to, good. So we take our inverse, and what do we end up with? 50 period. Okay. Okay. All right, last one. we got tangent of theta is equal to what? Okay. Alright, so when I take the inverse of that, what do we end up with? Okay. And I should get the exact same thing if I checked it with sine and cosine, right? For cosine, what would my ratio be?
14 over 8.
Good. And what would my ratio for sine be? Okay, and if we found the inverse of both of these, we would still get 61. Very good.